In 12 and 13 on the review, it says explain one way to start solving the following systems of equations using elimination. So when we look at number 12, what we want to do is kind of take a look at one of the variables. If I wanted to solve this using elimination, we need the same coefficient but opposite signs. So I could multiply this equation by 3 to get a 6x. If I have a positive 6x here, I would need a negative 6x here. So we would multiply by negative 2. So one option would be to multiply the first equation by 3, the second equation by negative 2. We can also switch that with our signs. We can multiply this by negative 3 and this by positive 2. Another option, look at your y's. I have a plus 5y and a negative 2. Their least common multiple here would be 10. So we could multiply the first equation by 2 to get 10y, and I can multiply the second equation by positive 5 to get a negative 10. So then we have positive 10, negative 10. It doesn't matter what we write down in our wording here as long as it is correct. So I'm going to state one way to solve this system by elimination is to multiply the top equation by 2 and the bottom equation by 5. This way, I would get a 10y and a negative 10y. And again, there are multiple answers that you can give here. All right, number 13. We can take a look at our x's first. And I have a 2x and an x, so we want same number, opposite signs. So all we need to do here is multiply the second equation by negative 2. If we wanted to look at our y's, I have a 3y and a negative y. We can make it 3y and a negative 3y. So we would multiply our second equation by 3. Okay, so I'm going to state one way to solve this system by elimination is to multiply the bottom equation by negative 2. Again, we could also multiply the second equation by 3, and that would work as well. For numbers 14 through 16, it says solve the system using any method. Write your answers as ordered pairs on the line, provided you must show your work. Well, in number 14, I see that the y is isolated in the top equation. Therefore, I'm going to take what y equals, which is 2x plus 5, and I'm going to replace the y in the second equation. So I'm using substitution. I'm going to combine my like terms. Subtract 5 from both sides. Then divide both sides by 5. We get x equals 1. Now I'm going to solve for y by plugging x into that first equation. We said x equals 1, so I get 2 plus 5 equals 7. So we get that x is 1, y is 7. Okay, and number 15. Since I have these in standard form, ax plus by equals c, all of them have coefficients other than 1, I am going to solve by elimination. I'm going to eliminate my x's. I'm going to multiply my second equation by negative 3. So I'm going to rewrite my first. We're not changing that. My second equation will become negative 6x minus 9y equals negative 15. But now I have the same coefficient in front of x, but with opposite signs. So I can add 6x plus negative 6x cancels out, it's 0. 5y plus a negative 9y is negative 4y. 19 plus a negative 15 is 4. I divide both sides by negative 4. We get that y equals negative 1. Now I'm going to substitute this negative 1 back into an equation. I'm going to use the first one. It doesn't matter which one you use. You should get the same answer for x regardless. So I get 6x minus 5 equals 19. Now I'm going to add 5 to both sides. We get 6x equals 24. Divide both sides by 6. We get x equals 4. So x is 4, y was negative 1. Okay, and the next one. This one, it really is personal preference. You could use elimination because they're both written in standard form, or you could notice that the y has a coefficient of 1 and subtract 3x from both sides and use substitution. This one is personal preference here. For me, I personally like to use elimination when they're already in standard form. I'm going to multiply my top equation here by negative 4 to eliminate my y's. Now I can add them. I get negative 14x, my y's cancel, equals 28. Divide both sides by negative 14, and x will equal negative 2. Pick an equation to substitute that x into. I'm just going to use the first one. We get negative 6 plus y equals negative 7. Then we add 6 to both sides, and we get y equals negative 1. So x was negative 2, y was negative 1.